Our little presentation about circles. 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 A circle is a shape of Euclidean geometry that is the set of points in the same plane that are equidistant from a given point. The center is called the radius. A circle is an intersecting geometry figure that has many practical applications such as a wheel. 1. Central angles. Arc. It is a part of a circle. Central angle. Circle of an angle whose vertex is at the circle of circle. In the figure, arc AB is the arc while C serves as the central angle. Different kinds of arcs. Minor. In the figure, it is arc AB which is the minor arc. Major. The figure YWZ serves as the major arc. Semicircle. Arc LMN and NOL are semicircles because it is half the circle. The degree measure of an arc is defined in terms. Degree measure of minor. It is equal to the degree measure of central angle. Arc KF equals to angle KXF. Degree measure of major. It is equal to 360 minus the degree measure of central angle. Arc MNA equals to 360 minus angle DGE. Degree measure of semicircle. Arc is equal to 180. TUV is equals to 180. Congruent circles. Circles with same radius. Congruent arcs. Arcs with same measures. Central angle intercepted arc postulate. The measure of central angle of a circle is equal to the measure of its intercepted arc. Arc addition postulate. The given point is the arc. Then arc AC equals arc AB plus arc BC. 2. Inscribe angles. In the figure, the first figure is the inscribed angles, while second and third is not. Inscribed angle theorem. The measure of an angle is one half the measure of its intercepted arc. Angle ARO is inscribed in the central angle D and line AR. Angle ARO equals one half the arc AO. Arc AO minus twice and angle ARO equals one half arc AO. The semicircle theorem. An angle inscribed in a semicircle is right angle. Inscribed angles in same arc theorem. Two or more angles inscribed in the same arc are congruent. Arc AC has two inscribed angles, angle D and angle C. 3. Tangents. Tangent to a circle. A line in the plane of the circle intersects the circle at exactly one point is called tangent line. The point of intersection is called point of tangency. A circle separates a plane into three points, interior, exterior, and the circle itself. A is the point of tangency. R is the exterior of central angle F. E is the interior of central angle F. Tangent line theorem. If a line is tangent to a circle, then it is perpendicular to a radius at its outer endpoint. Line AP is tangent to central angle C at P. Converse of tangent line theorem. In a plane, if a line is perpendicular to a radius of a circle at the endpoint of the circle, then the line is tangent to a circle. The radius x is perpendicular to line TR and AB. Tangent segments theorem. If two segments are drawn to a circle from an external point, the two tangent segments are congruent. The angles between tangent segments and line joining the external point to the center circle are congruent. Line ED and line EU are tangent to central angle C. Tangent circles theorem. If two circles are tangent internally or externally, then their line of center passes through the point of contact. Definitions. Tangent circles, two circles or whose intersection is exactly one point. Line of centers, the segment joining the center of two circles. Common tangent, a line which is tangent to two circles. Common internal tangent, a common tangent which intersects the line of tangent. External tangent, a common tangent which does not intersect the line of centers. Tangent circles whose common tangent does not intersect. Tangent circles whose common tangents are not intersect. 4. Chords and arcs. The perpendicular from the center of circles to any chord bisects the chord. Line HC is perpendicular to line BO which bisects the line joining the center of the circle to the midpoint of any chord which is not diameter is perpendicular to the chord. The perpendicular bisector of a chord of a circle passes through the center of circle. The perpendicular bisector of a chord of a circle bisects the central angles subtended by the circle. The bisector of a central angle subtended by the chord is the perpendicular bisector of the chord. In the same circle or in congruent circles, chords are congruent if and only if their distance from the center of circle are equal. Central angle Q with line Q are congruent, line to Q is line Q are perpendicular to AB. In a circle or in congruent circles, two minor arcs are congruent if and only if the corresponding chords are congruent. 5. Angles formed by secants, tangents, and chords. Intersecting secants exterior theorem. The measure of an angle formed by two secants that intersects the exterior of circle is one half the difference of its intercepted arc. Angle A equals half arc BC and DE. The measure of an angle formed by a tangent and secant drawn of the measure point of contact is half measure of its intercepted arc. Angle ABC equals one half arc AB. Intersecting secants. The measure of an angle formed by two secants intersecting in the interior of the circle is equal to one half the sum of measure of its arcs. Line AB intersects line CD at P. Angle DBP equals one half arc BD plus arc AC. 6. Power theorem. Intersecting segments of chords power theorem. If two chords intersect in the interior of circle, then the product of the lengths of the segments of one chord is equal to the product length of the segments of one chord. Chords line AB and CD intersects at K. Segments of secants power theorem. If two secants intersect the exterior of the circle, the product of the length of secant segment and the length of its external part is equal to the product of the length of the other secant segment and the length of its external point. Tangent secant segments power theorem. If a tangent segment of a secant is intersect in the exterior of a circle, then the square of the length of the tangent segment is equal to the product of the length of the secant segment and its external point. Line PQ is tangent to segment and line AQ is a secant tangent.